Let's review the climate change questions for the second semester exam. The first question says, define a positive feedback loop which is destabilizing, and give an example of one that pertains to climate change. Well, it kind of defines it right here when it says it's destabilizing, but a positive feedback loop is one that amplifies or enhances a change. I kind of like to think about it as like the one that gets out of control. So, for example, when ice starts to melt on Earth's surface, then what happens is there's more dark ocean exposed, which means that dark absorbs more infrared radiation from the sun, which then warms the climate, which then melts the ice, in which more dark ocean is exposed, which absorbs more infrared radiation, which warms the climate, and so on and so on. So you can see that it's just accelerating this change. Let's take a look at number 41. When your blood glucose level rises, your pancreas responds by secreting insulin. This has a lot of effects, but collectively, it decreases your blood sugar back to the normal level. So this would be considered a negative feedback loop because it is stabilizing. It's getting things back to equilibrium, if you will. 42 says, complete the following diagram to show how infrared radiation interacts with a greenhouse gas. Well, as that infrared radiation comes into our atmosphere, normally it would radiate back to outer space, but it gets absorbed by greenhouse gases like carbon dioxide, and it can get re-emitted back toward Earth's surface. And so effectively, it's trapped in our atmosphere for a longer amount of time. So that's what's happening to the radiation. Rather than leave to outer space, it gets trapped. And based on the picture here, there's really only one greenhouse gas that this could be, and that is carbon dioxide, because I can see carbon surrounded by those two red atoms, which are the oxygen atoms. And there are other greenhouse gases as well. Methane and water vapor are notable greenhouse gases. There could be a lot of different sources of this CO2. For example, the combustion of fuel, and specifically a fossil fuel. '43 asks you to describe the change in the carbon cycle between the hydrosphere and the atmosphere that would be caused by an increase in CO2 emissions. Well, if there is an increase in CO2 in the atmosphere, more gets dissolved. More CO2 is dissolved in the ocean, the hydrosphere. And as we learned about in class, this actually turns into carbonic acid in the ocean, which lowers the pH, which has caused all sorts of different changes. 44 asks you to draw the relationship between the biosphere and the atmosphere and their roles. So we'll keep this pretty simple. I've got a person representing animals, I've got a tree, and I've got my sun up here so we can see where the atmosphere is. CO2 in the atmosphere is taken up by trees in the process called photosynthesis, this is a carbon sink. And there is cellular respiration as well, but these rapidly growing trees, for the most part, are sinking CO2 more than they're releasing it. And then humans and animals breathe oxygen and release CO2, and so that increases the amount of CO2 in the atmosphere. And of course there are a lot more things going on, but we would call this a carbon source. The sphere of the Earth that has unused fossil fuels is the geosphere. And it's pretty interesting because it really takes hundreds of millions of years in order to form fossil fuels. And as I mentioned earlier, fossil fuels form when you've got buried deposits of organic materials and they're exposed to heat and pressure in the Earth's crust. Eventually they turn into fossil fuels. So we do have a lot of predictions, and they are definitely in our lifetime of when we will run out of fossil fuels. The rate of temperature change in the past 20 years compared to the past 20 million years, Earth has seen an increased rate in temperature change. Going up. It says you decide to study the change in Arctic sea ice from the years 1979 to 2009. You graph your data and you get a best fit line. Using this equation, predict the year where there will be 0 million square kilometers of sea ice, assuming this trend continues. So I can see starting back in like 1979 that there were almost 8 million square kilometers of Arctic sea ice. And in the year 2009, we were down, looks like underneath 6 million square kilometers. So I see a decrease over time in the Arctic sea ice. So let's use this graph. If I set y equal to 0 million square kilometers, I can figure out the year, which is x, that we're going to hit 0. So in order to do that, first I need to subtract 176.55 from both sides. So I'm going to have negative 176.55 equals negative 0.0852x. And I'm going to divide both sides by negative 0.0852. And x in my calculator, when I do that, is equal to the year 2072, which is kind of crazy to think about. It's 2017 now. That is 55 years away. Describe the impact on the climate for each of these scenarios. What if cities use more electric and hydrogen fuel celled vehicles? Well, over time that could decrease the amount of CO2 in the atmosphere, which would lower the average surface temperature of the Earth. If we get rid of a bunch of trees, that is going to increase the amount of CO2 in the atmosphere because we'll have less of those carbon sinks, and so that would have an increase on temperature. If we have labs that create meat and then all of a sudden we don't need as many cattle release a lot of methane gas, and so this is going to decrease the amount of methane, which will decrease the temperature because, again, methane is one of those greenhouse gases. Describe how the events may influence climate change on the short term and the long term scale, and specify if it is going to have an effect on the input, output, storage, or redistribution of energy. So, first one says that you've got a volcano and it produces dark light blocking out the clouds in the atmosphere. Well, the sun, this is our atmosphere here. If we've got this ash blocking the input of sun's energy, it's going to get reflected off, and so that is going to lead to, in the short term, a cooling effect. It will increase the reflection of energy. So, in other words, it will decrease the input of energy into our atmosphere. In the long term, however, it's going to be adding carbon dioxide because the volcano, when it erupts, it adds greenhouse gases, and so that will result in an increase in temperature because it will have the greenhouse gas effect due to that increased amount of CO2. And so that's going to decrease the output of energy, since there will be that lingering amount of infrared radiation in our atmosphere. What if there's an increase in the number of sunspots that also increase the amount of infrared radiation released by the sun? Well, this is definitely a cycle, and so in the short term, if there's an increase in sunspots, that's going to increase the energy input, and it will increase the temperature. And we studied in class that the number of sunspots on the sun does fluctuate. If the amount of ice on the surface of the earth grows and more energy is reflected back into space, this is going to result in a decrease in temperature in the short term. And then depending on other factors, it could, in the long term as well, end up decreasing the temperature, forming more ice, reflecting more light into space, decreasing the temperature even more. That's how we got into the Ice Age.